All right, let's talk about C programming. Today we're going to unravel some of the core ideas that honestly cause some of the most mysterious and frustrating bugs. Variables, where you can see them, and, most importantly, how long they actually stick around in your computer's memory.
You know that feeling, right? Where your code just does something weird. A variable suddenly doesn't have the value you swear you gave it, or the whole program just crashes out of nowhere. Well, the answer is almost always hiding in how C manages its memory, and we're going to pull back that curtain right now.
So here's our game plan. We're going to start with a really simple way to picture your code's memory. Then we'll talk about functions, scope, and lifetime. After that, we'll get into the super useful static keyword, and we'll finish with what is, without a doubt, the most dangerous mistake you can make with memory in C. And don't worry, we're going to build it all up step by step.
Okay, first things first. How do we even think about memory? Well, to make sense of all this, let's use a powerful analogy. I want you to imagine that your entire C program is a house.
It's a really simple way to picture it, but it's incredibly effective. The program itself is the whole house. Every function you write, that's a different room inside the house. A kitchen, a workshop, whatever. And your variables? Those are just the tools you use inside each room to get a job done.
So let's step into one of these rooms. When your code calls a function, it's like walking into a workshop to do one specific task. And for that task, you bring in a specific set of tools.
These tools, we call them local variables. They're temporary. They only exist while you're inside that function's room. The second that function is done and you walk out, poof, the tools are gone. That's because they're stored in a temporary memory area called the stack, which gets wiped clean after the job is finished.
Next up, scope. And with our house analogy, this is a super simple idea. Scope is all about what you can see from where you're standing. Can you only see a tool when you're inside one specific room, or is it something, like the main water valve, that's visible from anywhere in the house?
This really lays it all out. Local variables are like a hammer you're holding in your hand. You can only use it while you're in that room. But global variables, they're like the house's main power switch. You can access it from any room, which is powerful, but you've got to be really careful, because flipping it in the kitchen affects the entire house.
So here's a fun one. What happens when a local tool in your hand has the same name as a global utility for the whole house? This is a really cool concept called shadowing. Take a look at this code and see if you can guess what it prints.
Okay, check this out. We've got a global variable x, and we set it to 1. But then, inside our function, we create a brand new local variable, also named x, and set that one to 10. So when we call printf, which x wins, the global one or the local one?
And the output is 10. Here's the key takeaway. The local variable always takes priority inside its own room. It effectively casts a shadow over the global one. So from inside that function, the global x is completely hidden from view.
Okay, so we've got scope down. That's where a variable is visible. But now let's talk about lifetime, which is how long that variable actually sticks around in memory. They sound kind of similar, but trust me, they are two very different and very important ideas.
Lifetime is just the fancy term for how long a variable gets to live in memory. Most of those local variables we talked about have an automatic lifetime. They're born when the function starts, and they're destroyed the moment it ends. They're temporary. But global variables, they have a static lifetime. They're created when your program first boots up, and they only disappear when the program shuts down completely.
And this is where it gets really interesting when we start to bend the rules. What if you wanted a tool that was only visible inside one room, so local scope, but you wanted it to stick around even after you left? That's precisely what the static keyword was invented for. A static local variable is amazing. Think of it like a special tool that you bolt to the workbench in your workshop. It's still only usable inside that one room, but when you leave and come back later, the tool is right there exactly how you left it. It gets initialized only once, and it actually remembers its value between function calls.
This is the classic example that just makes it all click. Take a look at this counter function. What do you think is going to happen? What will it print if we call it, say, 3 times in a row?
Now, the absolute magic here is that little static keyword. Because count is static, that line, static int count equals 0, that only runs one time, the very first time the function is ever called. Every time after that, the function just uses the value that count already has. And so, the output is 1, then 2, then 3. This is such a great illustration of the concept.
The count variable holds on to its value between calls. If you took away the word static, what would happen? It would just print 111, because a normal local variable would be created and reset to 0 every single time. Big difference.
And that brings us to our grand finale, the most dangerous mistake. Look, understanding scope and lifetime isn't just for exams. It's what helps us avoid some of the nastiest, hardest to find bugs in all of C programming. Okay, look really closely at this code snippet. The function createVar makes a local variable, x, and then it returns its memory address. Seems useful, right? I mean, we're getting a pointer to the number 10. But based on everything we've just talked about, is this really safe?
So this function is promising to give us the location of x. But just think back for a second. What did we just learn about the lifetime of a normal local variable like x? Remember? It's temporary.
No, this is so not safe. In fact, this is one of the all-time classic, most dangerous mistakes you can make in C. It leads to something called undefined behavior, which is basically a programmer's worst nightmare. Your program might crash, it might spit out garbage data, or, and this is the worst part, it might seem to work just fine until one day it fails spectacularly for no apparent reason.
And the analogy on this slide is just perfect. As soon as the createVar function finishes, the memory for x, its room, is demolished. It's gone. The pointer you got back is now what we call a dangling pointer. It's a key to a room that has been knocked down. You're pointing at nothing but rubble. So to wrap it all up, the main thing to burn into your brain is this. Scope is about visibility, but lifetime is about existence in memory. This table here summarizes everything perfectly. Your normal local variables are temporary tools on the stack. Globals are like house utilities that last forever. And static locals give you the best of both. A private, persistent tool that stays in its room for the life of the program. So now that you have the blueprint of the house, where are you going to look for those subtle bugs in your own code?